Hi, hello everyone.
Today we are going to discuss the most important chapter, Introduction to Trigonometry. Generally, what do we know about trigonometry? Trigonometry is nothing but a real life applications of the whatever we have learnt earlier. That is the right angle triangles, Pythagoras theorem, etc. All these applications in our real life. That is trigonometry. So this is the most important chapter in wherever we go in our life. This will be very useful. So without doing any late, we will go into the topic. See here, introduction to trigonometry. See here, here there is an introduction. You have already studied about triangles and in particular right triangles in your earlier classes. Yeah, in earlier classes only from 8 9 we have studied about triangles and also right angle triangles, particularly properties of the triangles, mainly Pythagoras theorem, etc. So let us take some examples from our surroundings where right triangles can be imagined to be formed. See here. In our general life, where we get right angles and triangles. See here, they have given some examples. We will do first. We will see this. Suppose that students of a school are visiting Qutub Minar. Now, if a student is looking at the top of the Qutub Minar, a right triangle can be imagined to be made as shown in figure 8.1. Can the student find out the height of the Qutub Minar without actually measuring it? Yeah. See here, here there is a person and he is seeing the top of the Qutub Minar, and from some a distance he is to the Qutub Minar, there is some distance. Here we are getting right angle. By just measuring the angles, we can find this distance from the person to the Qutub Minar. So in this way, this trigonometry will be useful for us. See here, other example. Suppose a girl is sitting on the on the balcony of her house located on the bank of a river. She is looking down at a flower pot placed on a stair of a temple situated nearby on the other bank of the river. A right angle triangle is imagined to be made in this situation as shown in figure 8.2. If you know the height at which the person is sitting, can you find the width of the river? Yeah. If we know this height, we can find the width of the river, how much length it is flowing. And also by knowing the angle also we can find the trigonometry. Just please listen carefully so that we can we can understand this trigonometry easily. Just trigonometry is nothing but a real life application of right angle triangles in our daily life situations is called trigonometry. See here, another one they have given. Suppose a hot air balloon is flying in air like this. Two hot air balloons are flying and a girl happens to spot the balloon in the sky and runs to her mother to tell her about it. Her mother rushes out of the house to look at the balloon, and now when the girl had spotted the balloon, initially it was a point at point A. When both the mother and daughter came out to see it, it had already traveled to another point B. Can you find the altitude of B from the ground? See here. We can find the height of the balloon from the ground, and also we can find the distance. In this way trigonometry is useful. See here, in all the situations given above, the distances or heights can be found by using some mathematical techniques which come under a branch of mathematics under trigonometry. The word trigonometry is derived from Greek words. Trio means three, gon means sides, and metron meaning measure. Three sides measure. In fact, trigonometry is the study of relationships between side and angles of the triangle. The earliest known work on trigonometry has recorded in Egypt and Babylon. Early astronomers used to find out nothing. This is trigonometry. You have to know this one. Trigonometry comes from the Greek words tri, gon, metron. Tri means three, gon means sides, metron means measure. Three sides measure, and it is the relationship between the sides and angles of a triangle. In this chapter, we will find the ratios and of the sides of right angle triangle, trigonometric ratios of the triangle. We will restrict our discussion to acute angles only. However, these ratios can be extended to other angles also. See here, measure 0 degrees to 9. Acute angle, we know no. Acute angle is nothing but less than 90. That is between 0 to 90 degrees. We will calculate the trigonometric ratios for some specific angles and establish some identities involving these ratios called trigonometric identities. See here, trigonometric ratios. In section 8.1, you have seen some right triangles imagined to be formed in such situations. Yeah. Let us take a right triangle ABC as shown in figure. See, this is the ABC triangle. In this, first what you know, basics of trigonometry, first you should know about sides of the triangles. Which one will be opposite side, adjacent side, hypotenuse. This is the major basic for trigonometry. See here, suppose this is a triangle ABC. A, B and C. This is the right angle triangle. Here angle B is the right angle. So now just what do you know? First, if we take angle C, ACA, angle ACA, ACB, ACB. For this you should know what is adjacent side, what is for a triangle, right angle triangle, hypotenuse is fixed. Longest side will be the hypotenuse. And for angle C, AB will be opposite, OS. Opposite side is AB. AB is the opposite side. And adjacent, this is the opposite side. And adjacent side will be AS, adjacent side. Adjacent side will be BC. Means whatever the side touching the angle will become adjacent side. And whatever the side that is opposite to this angle will be opposite side. And hypotenuse is fixed. Longest side will be the hypotenuse. So if we take angle A, if this is angle A, means CAB, angle CAB. Today I will just discuss the basics of trigonometry, and in the next video I will make sure to answer some examples from exercise, etc. And for angle CAB, opposite side will be, for this opposite side will be BC. Opposite side. Opposite side will be BC. And adjacent side will be AB, the side touching it. Adjacent side will be AB, like this. For this triangle, like this. If we change the XYZ like the triangles, we can also, the opposite side and adjacent sides will also be changed. Wherever you go, you just remember this one. For any triangle, the side opposite to it will become opposite side. And the side which is touching this will become adjacent side, and hypotenuse will be fixed. See here, for this triangle ACB, B is the right angle triangle, same how I told you. Here angle CAB is an acute angle. Here this is an acute angle. Note the position of the side BC with respect to the angle A. It faces angle A. We call it the side opposite to angle A. That is nothing but AC is the hypotenuse, we know. And side AB is part of angle A. So it will be called as adjacent side. And side opposite we will call it as opposite side. For angle A, BC will be opposite and AB will be adjacent. First you must know which one is adjacent side, which one is opposite side. This will be main. Next, coming to the trigonometric ratios. Note that position of the sides change when you consider angle C in place of angle A. Yeah, whenever angle is changing, you need to just check which side is opposite and which side is adjacent. There only most of the people will get confused. See here. Next, you have studied the concept of ratio in your earlier classes. We now define certain ratios involving the sides of right triangle, and call them trigonometric ratios. See here, for a right angle triangles, there will be some trigonometric ratios. The trigonometric ratios of the angle A in right angle triangle ABC are defined below. First, I will just will tell the generalized trigonometric ratios. Generally, we are having, just wait, I will rub this one so that we will have clean board. Next, now see here, first I am telling generalized. First, we will be having main ratios, three trigonometric ratios. First one is sin theta, a sine angle represented by sin theta. I am taking theta. Sin theta, cos theta. These are the basic first two trigonometric ratios. These are the main. From these two, we can derive tan theta. Tan. These are the three trigonometric ratios. Next, from this only we will get the other three trigonometric ratios. From sin theta, reversing the sin theta, we will get cosine theta. Just a minute, I will cross check it. Cosine or cosecant? Cosecant theta, yeah. Cosecant theta. Cosecant theta. And cosecant theta. And for cos theta, inverse of cos theta will be secant theta. Secant theta. And inverse of tan theta will be cot theta. The whole trigonometry lies in these six ratios only. Cot theta. See here, sin theta. First, sin theta is nothing but opposite side over hypotenuse. Opposite side over hypotenuse. I am simply representing it as H. And cos theta will be adjacent side over hypotenuse. Cos theta, adjacent side over hypotenuse. And tan theta will be opposite side over adjacent side. That is nothing but sin theta over cos theta. Opposite side over adjacent side. Here we won't get any hypotenuse. That is nothing but sin theta. Theta is nothing but angle. Sin angle over cos angle. This is the sin theta equals to opposite side over hypotenuse. Cos theta will be adjacent side over hypotenuse. Tan theta will be opposite side over adjacent side. That is nothing but sin theta over cos theta. Now coming to the other three trigonometric ratios. Cosecant theta. Cosecant theta is nothing but inverse of sin theta. Inverse of sin theta. Inverse of sin theta means hypotenuse over adjacent side. Hypotenuse over hypotenuse over opposite side. And secant theta. Secant theta is nothing but inverse of cos theta. So 1 over cos theta, that is nothing but hypotenuse over adjacent side. Cosecant theta, hypotenuse over opposite side. Secant theta, hypotenuse over adjacent side. And coming to the last but not least, cot theta. Cot theta is nothing but inverse of tan theta, 1 over tan theta. Inverse of tan theta, that is nothing but adjacent side over hypotenuse. We can just inverse the values and we can take them. Adjacent side over opposite side. See here, the whole trigonometry will be lying in these six ratios only. And also, first you need to know which is for an angle. If I give you an angle, you have to just tell me which one will be opposite side and which one will be adjacent side. If you know that thing and these six ratios, the whole trigonometry is nothing. Mainly people will confuse because of this one. You just remember, you have to by heart these ratios exactly. See here, sin theta equals to opposite side over hypotenuse, cos theta equals to adjacent side over hypotenuse, tan theta will be opposite side over adjacent side, sin over cos, and cosecant theta will be 1 over sin theta, that is h hypotenuse over opposite side, and secant theta will be 1 over cos theta, inverse of cos theta, that is nothing but hypotenuse over adjacent side, and cot theta will be nothing but inverse of tan theta, that is adjacent side over opposite side. Next, we have done with the ratios now. Just now we will have a simple overlook of these ratios. See here, this is the triangle, and for angle A we are considering And for angle A, this CB will be opposite and AB will be adjacent. Hypotenuse is same. See here, sine of angle A means for angle we will calculate sine theta, sine 30, sine 40 like that. Sine of angle A will be side opposite to A. For opposite A we will be having BC, no? So BC over hypotenuse, BC over AC. And cosine of angle A, side adjacent to angle A over hypotenuse. This is AB over AC. And tangent of angle A, side opposite to angle A over side adjacent to angle A. That is nothing but BC over AB. Opposite side over hypotenuse for sine theta, adjacent side over hypotenuse for cosine theta. Cosine theta is nothing but cos theta. And for tangent, tan theta, it will be side opposite to angle A over side adjacent to angle A. And cosecant theta will be cosecant theta of angle A will be, cosecant of angle A will be 1 over sine theta, that is hypotenuse over opposite side. Secant theta will be 1 over cosine theta, means cos theta, that is hypotenuse over adjacent side. And cotangent of the ratio, cotangent theta will be 1 over tan theta, that is side adjacent to angle A over side opposite to angle A. This is about trigonometric ratios. See here, the ratios defined above are abbreviated as sin A, cos A, tan A, cosecant A, cosecant A, secant A and cot A respectively. These are the shortcuts. And note that ratios cosecant A, secant A and cot A are respectively the reciprocals of the ratios sine, cos and tan. Yeah, first if you know these three ratios, you can definitely derive the other three ratios easily. So you need to by heart these three ratios. In this also you have to by heart sine theta and cos theta. Sine theta is nothing but opposite side over hypotenuse. Cos theta will be adjacent side over hypotenuse. Why I am stressing this much is because the whole trigonometry lies in this ratio only. So the trigonometric ratios of an acute angle in a right triangle express the relationship between the angles and the length of its sides. Why don't you try to define the trigonometric ratios for angle C in the right triangle? Okay, we can just easily find. Let's check an example for today. See here, example 1. Given tan A equals to 4 by 3 and find the other trigonometric ratios. Don't see the answer, so we will try. First, I will not copy this to my board. See here. Here we are having a right angle triangle like this. A, C and B. See here. Here they have given tan A equals to, only this one we know. Tan A equals to 4 by 3. Is that correct? Yeah, 4 by 3. Okay. This is what we know. And here B is the right angle. From the figure we can know. So, first they are given angle. For angle A, opposite side will be CB and adjacent side will be, because here they have given tan theta, we must know opposite side and adjacent side. This will be adjacent side. So, here they have given the ratio as 4 by 3. So, we can take as 4x comma 3x. 4x comma 3x. Suppose I am taking 3x, but in the example they have given 3k. No matter what is the variable, we can just find. So opposite side, tan theta is nothing but opposite side over hypotenuse, no? Opposite side over adjacent side, no? Opposite side over adjacent side. So opposite side is CB, that is 4k. And adjacent side is 3, 3x, 4x. I will note it down, otherwise you will confuse. 4x. So Here we know the 4x and 3x. And what is the Pythagoras theorem? We know hypotenuse square equals to side square plus side square. No, hypotenuse square equals to side square plus side square. Here they asked us to find the other length of the other measures of all the three sides. Side 1 square plus side 2 square. So here we get hypotenuse equals to hypotenuse square. I am writing hypotenuse square equals to 4x square plus 4x whole square plus 3x whole square. So here hypotenuse square equals to 4x square is nothing but 4 16 x square. 16x square plus 3 3 is 9x square. 9x square. So what we will get? We will get 25x square. 25x square we will get. Hypotenuse square equals to 25x square. Hypotenuse equal to, if we transfer this whole square to that side, it will become square root. These are the basics. Hypotenuse equals to this 25x square, we can write it as 5x whole square. 5x whole square. So this square and root will get cancelled and h equals to 5x. So sides will be 3x, 4x and 5x. Let's check with this. See now, 3x, 4x and 5x. Till now what we got? We have got the values of that all sides. So when we know the values, we can just find the trigonometric ratios. No? So tan theta is 4/3. So from this sin theta will become sin theta will be opposite side over hypotenuse. No, opposite is 4. Hypotenuse is 5. So 4/5. Opposite side by hypotenuse 4/5. Next cos theta will be adjacent side over hypotenuse 3/5. These are the three ratios. From these three, we can calculate the other. Cosecant theta will be inverse of sin theta. So, cosecant theta equals to inverse of sin is nothing but 4/5 reverse. Inverse of 4/5, that is 5/4. 5/4. Secant theta will be inverse of cos theta. So, it will be 5/3. And inverse of tan theta will be cot theta. Cot theta is nothing but 3/4. This is how we find the trigonometric ratios when we know one ratio. Just simple. See here, let's cross check. Cot theta, sin theta will be 4/5. What whether we got? Sin theta will be 4/5. Cos theta will be 3/5. Cos theta will be 3/5. Cosecant theta will be 4/5. 5/4. Cosecant theta 5/4. And secant theta will be 5/3. 5/3. And cot theta will be 3/4. Cot theta 3/4. Yeah, this is how we solve the problem. Okay, for today this is enough, and from tomorrow we can do the other examples, and also I will start doing exercise problems so that you will be helpful in the schoolwork. If you like the video, please subscribe and comment for more videos. Thank you. Bye. And one more thing, I want to show my channel. Yeah, just a minute. I will open it. This is my channel. All of you please subscribe and support me. Thank you so much. In this channel, you will get more interesting videos about your science, maths, and physics, chemistry classes, and also biology, so that you will be somewhat. I will add some value to your education, so knowledge. Thank you so much. Bye, everyone.